So we're looking at probability number 4 from the probability packet, and we have these 5 cards, 1, 2, 3, 4, 5, that are lettered, and it's like a little deck of cards, and if we were to randomly pick one of these cards, we have some probabilities that we can answer here. So the probability of pulling an S out of this group of cards is 2 out of 5. There's 5 cards. And if you change that to percent, and we can think of it a number of ways, I'm going to go to make it 4 out of 10 or 40 out of 100, which is 40%. So we're going to try to write our probabilities both as fractions and percents whenever we can. So now we look at the next one and say, what's the probability of not choosing an S? Not S would be just these 3 out of 5. In fact, the rest of the cards. And 3 out of 5 is the same as 6 out of 10, which is the same as 60 out of 100, which is the same as 60%. So 60% of the time, you would choose a S, not an S. How about the probability of an I? Well, it looks like there's only 1 out of 5, which is 2 out of 10, which is 20 out of 100, which is 20%. So again, I'm just going to continue to work through problems in this set, going from fraction to percent in each case. Now this little symbol is a shortcut symbol, and it's the same as this symbol up here. So this is not, and so is that. So now we could just use that little symbol to mean not instead of having to write not all the time. So if this is the probability that it is an I, then the probability that it's not an I would have to be all the rest of the cards. 4 out of 5 cards, 1, 2, 3, 4 of the 5 are not I's. And so I'm going to change that to 8 out of 10 or 80 out of 100. Some of you may be able to just make this step and know right away that 4/5 is 80%. But I'm going to keep doing the steps in between. Now the next one should be pretty obvious. The probability of choosing a Q, let's see, no Q's is 0 out of 5. I'm not going to go through all that because I know it's just 0%. So let's keep going. Now, the other end of that, if the probability of choosing a Q is 0 out of 5, what's the probability of not choosing a Q? That's a little symbol again, means not Q. Well, all of them are not Q's, so the chance of that happening is, of course, all of them, 5 out of 5, which is 100%. When you get all of it, 100%. So that part takes care of using the cards that are above. And the ones below now are just looking at, if you know the probability of one thing, then you know the probability of the other part. In some cases we'll look at it as a percent, in other cases as a fraction. So if you know the probability of rain is 30%, what's the probability that there's no rain? Well, it would have to be the rest, because remember the whole is 100%. So if we have 30% of 100%, then the rest has to be 70%, because the 70% plus the 30% equals the 100%. So if the probability of winning the lottery is 1 in a million, that means the probability that you don't win the lottery is all the rest, or 999,999 out of 1 million. So it doesn't look like you have a very good chance of winning the lottery if there's a 1 in a million chance of winning. These are all the chances you have of losing. So if we look at number 9, probability of A, getting an A, I think this might be, maybe in class or on a test, is 3 out of 17. So the probability of not getting an A is all the rest. So if 17 is the whole amount, and 3 is this fraction or this part, then the rest, 14 out of 17, is the rest, because the 14 plus the 3 equals the 17, the whole amount. So I just took 3 from 17 to get that 14. And one last example, if the probability of not t is 21%, then the probability of t would have to be the rest. And so I'm just going to go ahead and think of this as 100% minus the 21% gives me the rest, the part that I need, and that's 79%. So 79% would be the rest. These two together have to add up to the whole, because the not and the part together make the whole 100%. We're looking at probabilities. So lots of work with percents and fractions, and we'll even look at some decimals with probability and finding parts of them.